help you with? Yeah.
Can you go over any question that's 7, 8, 9?
You got it. So let's take a look at, say, number 7. So we're going to do probability, brown hair, such that brown eyes. Okay, so think of this as being your denominator. Think of this being your numerator, okay? So it'll be brown eyes down here. This will be brown hair. But you go to the denominator first to figure out where you're looking. So we're going to, basically what we did doing in this situation is saying, okay, anybody with brown eyes, stand over here. So everyone else with other color eyes are over here. So now, then I walk over to the brown eye group, and I randomly select somebody with brown hair. Okay, so if I look at brown eyes, if I look at eye color, there's 23 people with brown eyes. So we're talking about 23 people we're talking about. If I want to know the brown hair, then I look in that same column. I say, okay, brown hair, there's 12 of them. So 12 out of 23. Does that make sense? So you look to this first, and that tells you I'm going with this, and then you look for how many are in that column. So it's basically like I took the 23 people with brown eyes, they're over here. I walk over and say, oh wow, there happens to be 12 of them with brown hair and brown eyes. And then everyone else with different color hair, different color eyes, or different color eyes would be over here. And those people would have a mix of brown hair, blonde hair, red hair, black hair. So, oh, we just got a funny email. What does it say? Okay. Oh, great. We have needed to switch CT games due to some things at their school. We will now host them on the 20. Oh, you told me something that's going to happen on the 21st and February 16th. Don't tell me things that far in advance.
Yeah, literally. I thought we were talking about tomorrow.
I'm holding out one more day.
Third day of school.
Go ahead.
That would have been so bad, dude. If we were tomorrow. If it was just like, oh yeah.
Okay, so I look over, I find the eye color.
Yeah.
So you go up to brown on the eye color, and you go all the way across. There's 23 people that have brown eyes,
Okay.
and then whatever hair color. And then, so that'll be my denominator. And then I say, okay, how many of those 23 people would also have brown hair? So it'd be 12 out of the 23.
Okay, you're not looking at the whole.
Not the whole. Because it has the given or that little vertical bar.
Okay.
So the vertical bar, to the right of the vertical bar, tells you what your denominator is going to be.
Oh, I think I was looking at 6.
Oh.
What number 6?
Okay, so what is the probability a person has brown eyes and brown hair? So you go to brown and brown, there happens to be 12, and there's 60 total because you're talking about the whole group.
Okay, that's the one.
Yeah.
Oh.
Any other questions you want me to hit? Yeah.
Wouldn't it be 28 over 23? Because
Whoa.
since there's 28 brown.
You're absolutely right. But there's 28 brown altogether. So what I'm going to do is I'm going to say, okay, anyone who has brown eyes,
Oh,
you stay in the classroom. Everyone else has to leave the classroom. So now everyone who's sitting in the classroom has brown eyes. Okay? Everyone out there has different color eyes. But all of those people with brown eyes also have all the different hair colors. Okay, so then I'm going to say, okay, now everyone here has brown eyes, yeah? Go out in the hall. make sure, take a look at your neighbor. Does anyone out here have brown eyes? And then they're like, no, we're all good. And then so I have 23 people sitting here. Then I say, okay, how many of those people have brown hair? So then I go, oh, there's 12 with brown hair and brown eyes.
Okay.
Any other questions? Seem okay? All right. So I want to look at 4 or 5. So I'm on the wrong page. As always, syrup's lost. You what? Yeehaw. All right, so I'm on still the wrong page. Golly, where is chi-squared? I'm on page 90 for 4 or 5, the Venn diagrams. So this is on page 90. So this is talking about a Venn diagram. And this is another way of relating to things. So Venn diagrams can be done a number of ways. First time, a simple way of a Venn diagram, you have a rectangle. The rectangle is like everybody included. Okay? So you create, if you're comparing 2 things, you create 2 overlapping circles. You're creating 3 things, you're creating 3 overlapping circles. 4 things, it gets a lot more complex to create 4 circles, and there's a different way I'll show you how to do that in Venn diagram. It's not totally necessary to know, but just so you're aware. So Venn diagram, this is one way to do it. So basically, you have, it'll usually say, if they don't tell you, they'll usually be a number here, there'll be a number here, be a number here, there'll be a number here. Okay? This is the shared portion. Okay, so let's say, you know, I know they're using drama and music, so let's just stay true to what they're doing. So drama and music. Let's say these are 2 different classes at the school. Okay, so there are 9 people in our survey that are only taking a drama class. In our survey, there would also be only 7 students that are taking music exclusively. The ones in the middle, there happens to be 15 people in the middle that are taking both the drama and the music class. And then the 12 outside, those 12 aren't taking, they're still at the school, but they're not taking a drama class or a music class. Maybe they're taking an art class or something. So there's a shared amount. So what would the total in our thing, total kids that would be taking drama be? What do you think? Yeah, there would be 24. What would be the total in the music? 22. Does that make sense? So I'm counting, so the overlap that takes place here, these guys are taking both classes. So if I want to know how many people are taking the drama, I add 9 and 15 together to get 24. If I want to see the music, I would say there's 15 plus 7, that would be giving me 22. Now, where sometimes they get a little dicey, and I'm kind of going away from this, I'm just trying to get us to have an understanding. How many are taking drama or music? I'm using the term or for a reason. This shared means they're doing drama and music, but how many are taking drama or music?
31.
16, yeah. You add these 2. So you're talking about the outsides, they're not taking a shirt. How many are taking this or that? So you're looking at people who are only taking drama or the people who are only taking music. So you add the 2 together. Okay? Yeah.
Will you take points off if you don't reduce that fraction?
No.
Okay, cool.
No, don't get silly like that. I mean, that's such an algebra 1 thing.
Okay.
It really is acceptable in the world of math to leave fractions as non-reduced. And the really sad thing, this will destroy your elementary school dreams. Remember mixed fractions? Those are not accepted in the math community. Improper fractions are, and I think the reason they did mixed fractions is, I remember in I think it was in 4th grade. It'd be like, I would always get picked on because I was the kid who wasn't paying attention. So the teacher would be like, Chris, you have 7/8 of one pizza left, and you have 2/3 of another pizza left. What do you have? Lunch! No, Chris. How much do we have left? And I think that's why they went with, you have, 1 1/3 pizzas left, or whatever it comes out to. I'm just arbitrary making it. But mixed numbers are not accepted mathematically. It's kind of frowned upon, but it was something that they did in elementary school to kind of sort of give you number sense. And then when you get a degree in math, you realize everything you really learned in elementary school was incorrect. It was just, so it was a big disappointment. So if you get a degree in math, which I would say go ahead and do, because if Stirrup can get a degree in math, you can get a degree in math. But there's just definitely some things that are disappointing. Also, when you take a class called P chemistry, it's called physical chemistry. Physical chemistry is calculus and probability mixed in with chemistry, and you find out that the octet rule is a big lie. You remember that? The valence, the octet rule always works. No. What about the F orbitals? S, P, D, and F orbitals. You start realizing why it doesn't work. I always give my wife grief because she still teaches that kind of stuff at Chemistry for Engineers. I'm like, yeah, but it's wrong. She goes, I have a PhD in chemistry. I know what I'm talking about. It's like, I know. So what about 3 2/3 of a pizza? All right, sorry. It's the arguments that take place in search house. So, hey, what does the 12 represent? What do you think? What would that outside 12 represent? Yeah, 12 people did not take either of those courses. They're still part of the survey. Then here comes the challenge. Here comes the challenge. Do I want to go this way? No, I don't want to go that way. I won't do that. All right, so probability, they like drama. And they already have the answer there. Okay. So, how many people like drama or took drama? What would you think? Do we just say it's the 9, or do we include the 15? Include the 15. So that's where you get the 24 as your numerator. But then you have to say, okay, how many people are we talking about? Okay, so I have 9 and 15. It's 24. 24 plus 7 is 31. 31 plus 12 is 43. Okay, so that's how they're generating those information. People that don't like drama. Okay, the people that don't like drama, and I know I did it, taking drama. I guess it's like versus not like. So these people obviously like drama. These people obviously like drama. These don't, and these don't. So you add those together, you get 19 out of the 43 total. Okay? The probability that they like drama and music. So how many people like both? It's the overlap. So you have 15 out of the total group of 43. And then they like drama and music. We did that. Okay? They like drama or music. Okay? This person likes drama. Or this person likes music. So I add those together, I get 16. And again, we still have 43 people we're talking about, including the 12 that dislike everything. And then when they say they like drama, given that vertical line, they like music, okay? So they like drama, given they like music. Let me make sure I do that right. They like drama, and they like music. So you have 15 that like drama, and then you have 22, you add those together, becomes your denominator. So you're like, okay, let's look at the music people. The 15 and the 7 like music, so that's 22 like the music. That whole group likes the music. But then you say, okay, how many like dramas? 15, got it. They like music. There's 22 of these people that like music, so our denominator becomes 22, so 15 out of 22. So on and so forth. Then you get to the 3-circle Venn diagram, which is on page 91. So the 3-circle Venn diagram, you still have some sort of rectangular square is your whole community. So then you do this. So this group here is so you have Spanish, chemistry, and math. That would mean these would be the people that are taking all 3 of the courses. Okay, so, oh man, I messed this up. Let's do this. Let's do the Venn diagram like they have it. So you have 2 circles here and here. Then you have your overlap here. You have 70, 3, 17, 15, 560, 85, and there happen to be 5 that aren't involved in any of these courses for whatever reason. Okay, good toss. All right, so you have to look and say, how many people are we talking about? If I add up all the numbers, there happens to be 260 people that are involved in this study. And that's just 70 and 3 and 17, 5, 15, 60, and 85, and the 5 that aren't involved that are just part of the school. So if you say, hey, how many people have all 3 classes? There's 15. Probability of the 3 classes, you have 15 people. So how many people would be doing Spanish and chemistry? Yeah, there are 3 out of the 260 that are just doing those 2 particular classes together. And then Spanish and math would be 5. Spanish and chemistry would be 60. How many people are taking math? You would add up the 85, 60, 15, and 5, because they are taking math of some sort. It's just that we're not worried about them. These 5 are part of the study. They just aren't taking any of those 3 classes for, again, whatever reason. Perhaps their counselor messed up and they goofed up their schedule. Okay? But then let's look at down below where they do the such at. Probability Spanish. And the student is in math. Okay? So, how many students are taking a math class? So I have 85 and 60. Let's see, let's go 85, that's 90, 150, 150. There's 165 people that are taking math. And how I got that number is I look at the circle that has math, I add all those numbers together, and I get the 165. And then, so now, what that's basically doing is you have this group of people saying, okay, everyone who's in a math class, stay in the classroom. Everyone who is not in a math class, go out in the hall. So now I have the people in the math class sitting there. And then I say, okay, what's the chance that you are in this math class, so you're all in here. Everyone else is out in the hall that's not in a math class. How many of you are taking Spanish? Well, there's two people who we have to consider, two groups. We have these 5 that are taking Spanish and math, these 15 that are taking Spanish, math, and chemistry, but that's part of the group because they're part of the circle of that. So there's 20 out of the 165. Okay, and that's where they come to. And again, notice these are not reducing fractions, which I told you don't have to do. Again, it is very acceptable to do this. There's times that you might see something on TV that would give, a lot of times statistical surveys, they will do this. A lot of times they will convert that into a percent. Should I make it a percent? It really becomes up to you. And I talked to you yesterday about if you're talking about your population. Okay. A lot of times a percent is used to influence the reader. A lot of times at 20 out of 165, the reader's not going to really be like, oh, that's not a big deal. Okay, but then if you convert it to a percent, then the percent can influence the reader to agreeing or disagreeing with you a little bit more. Okay? There's one last way Venn diagrams are done. And you don't necessarily need to know this. I just want you to be aware of it. I think I could draw this right. You make L's. Okay. Yeah. Let me erase that. Kind of do something like this. And then you take it out even further. And so if you start getting to more and more and more groups, you start doing this where this is the group that would be involved in all 4 activities. You don't need to know that for this class. I just want you to be aware if you ever take a stats class later and they start doing a Venn diagram and making an L, it's an overlapping pattern that does that. It's not vital to know, just for future reference, just in case you happen to find yourself in some stats class going, everything I learned in the stirrups class was wrong. It's not my meaning and doing, but go with that. Let's see. You guys want a lot of homework tonight? Okay. How about we look at page 211 and look at one. Let's look at 1 through 9. Sound like a deal?
Yes.
Cool.